Hello, this is Mr. Craig, and I want to talk about acids in this video. So continuing with the naming of compounds and formulas, naming acids, pretty important. First thing that I have here is, what is an acid? Or even better yet, how do I identify an acid or recognize an acid? Well, I'm going to tell you, if you see a hydrogen at the beginning of the compound, you're looking at an acid, most of the time. There are a few exceptions, but hopefully on your tests or quizzes whenever you're doing a naming compounds or formulas or whatever, if it has a hydrogen at the beginning, you're looking at an acid. Now, this is not to discuss the type of acid that we have, whether it's strong or weak, which we'll talk about much later on, but also what an acid does is pretty important to solutions, which we'll talk about later on. But when you look at an acidic thing, or an acid, it actually breaks down into hydrogen ions and chlorine ions. And it's the hydrogen ion that's really significant here in determining whether a solution is acidic or basic. But we're not going to name bases in this video. So since the hydrogen is so important, we put it at the beginning. So you can recognize that we have an acid because it starts with a hydrogen, or in some cases, more than one hydrogen. If you see a hydrogen in the middle, we don't really know if that's just an organic compound or it could be a base, but we'll talk about that much later on as well. But if it starts with a hydrogen, you're looking at an acid. All right, let's talk about naming these now. Okay. So the first thing the first type of acids that we want to look at are the acids that have no oxygen in it. Since there's no oxygen in this, every single acid name has to begin with hydro. Hydro means there's no oxygen in this compound. And I've got a few examples up here that we'll name. And the first thing you want to do is identify and ask yourself, is there an oxygen in there? If there's not, we're going to start the acid name off with hydro. All right. Now, when you do this, probably the best way to do this is to cover up the hydrogen to find your nonmetal. And we'll do that on the other ones as well. So when you cover up the hydrogen and you find your nonmetal, we'll name it the same way. It's like, okay, Cl is chlorine. So what we want to do is we want to drop what we would call, normally this would be a hydrochloride solution. Well, we're going to drop the IDE ending, or if you wanted to drop the INE ending, okay, we're going to drop the last syllable and we're going to make it an ic. Okay? So we're going to have not chlorine or chloride, but chloric. Since there's no oxygen in this, we call this hydrochloric. And then don't forget, put the word acid on it. So hydrochloric acid. And then if you want to hyphenate that or put that all together, that's your call. All right. If you're in my class, you can hyphenate it. If you wanted to put it together, no problem. All right. So let's look at the next one. Here we have a bromine, okay? So if we were to name this as a compound, we'd drop the INE and put bromide. But since there's no oxygen, we're definitely going to write hydro in front of it. And then, since we have bromine, and then we're going to drop the last syllable and put ic. So hydrobromic acid. Again, hydro means that there's no oxygen whatsoever in here. Okay? All right, looking at this one. Now you'll notice that there's two hydrogens on here. And I also want you to realize that when we look at naming compounds, hydrogen can act as a metal or a non-metal in some cases. However, based on the way that acids behave, we treat those as ionic compounds. So we're not going to identify and say that there's two hydrogens on here by using the Greek prefixes, di, tri, and all that other stuff. So we don't have to worry about how many hydrogens, because balancing out charges, hydrogen always is going to have a +1 charge when it stands in front. So in this case here, we have two hydrogens because the sulfur has a -2 charge. So we have to balance out the charges. So since hydrogen has a +1, we need two of those. That's why I have the subscript there. However, what's really neat with ionic compounds, you don't have to do anything special here. Since there's no oxygen, we just say hydro. And then if you look at, we have sulfur, so we would have a sulfide. Since we have sulfide, we make it sulfic. Okay? So hydrosulfic acid. Sounds a little funny, but hey, it still works. So again, the hydro is used because there's no oxygen. And then we drop the last syllable, in this case it would be the ide, sulfide, and put ic. And of course, acid. And then the last one here, again, cover that up. We've got phosphorus, so phosphide. But since there's no oxygen, you got your hydro. And then your phosphide is now phosphic. So phosphic acid. Okay? So again, looking at these kinds of acids, if there's no oxygen, you have hydro. And probably more important, these should all end in ic, since there's no oxygen, and you're going to be looking at a non-metal. So these are elements, non-metals. Okay. The next type of acids that we'll look at are acids with oxygen. So since these acids have oxygen, generally we're looking at a polyatomic ion. And so it's nice to identify the polyatomic. So in this case here we have C2H3O2, which everybody knows is, right, acetate. So since it ends in ATE, we're going to put ic at the end. Also, does this have oxygen? Well, hopefully. But in the last set, where we talked about the acids with no oxygen, we put hydro in front of it. If it has oxygen, don't even think about putting hydro in front of it. So what's really neat is we have our acetate, so we're going to get rid of the ATE ending and make it ic. So it'll be acetic acid. Okay? Now acetic acid just means that you have an acetate ion. The acid obviously means that hydrogen begins this. Okay, so acetic acid is you have your, whatever the charges are, so that acetate's -1, hydrogen's +1, there it is. So if you were working in the reverse direction, and I gave you acetic acid, you would know, oh, okay, since there's no hydro in the front of this, then that means that there is oxygen in this, and since it has the acetate, if I changed out or swapped out the ICE and put ATE, I now have acetate. So this is how you can go from the name to the formula, or the formula to the name. All right, looking at, oh, before I go to that, now this is, if you're ATE ending, what does ITE mean? That's right, it means it has one less oxygen than its normal polyatomic name. So if it ends in ITE, we're not going to have ic, we're actually going to have OUS as our ending, okay? So if it ends in ITE, your polyatomic ends in ITE because you removed one oxygen from your original 10 polyatomics that you have memorized. It's going to end in OUS. All right. So let's look at this one. HClO3. Cover up the hydrogen there. Hopefully you recognize, oh, that's one of my 10 polyatomics. That's chlorate. So since I have chlorate, actually let me write that out. Okay. I have a chlorate ion in here. Well, I'm going to get rid of the ATE ending and put ic. So now I've got chloric and then the acid. Again, no hydro. Okay. Again, I have an acid that has 2 hydrogens. The reason why is because this polyatomic, which is what? Correct, carbonate. Carbonate has a -2 charge. Since carbonate has a -2 charge and hydrogen has a +1 charge, we have to show 2 of those. That's why that has 2. However, everything's still the same. Since we have oxygen, we have our carbonate. Okay. So you have your carbonate ion, except we want to get rid of the ATE ending and put ICE on the end of that. Okay, so we have carbonic acid. Some of you may have heard that. That's actually in soft drinks, carbonic acid. Actually, it's in water when you allow it to be exposed to carbon dioxide, which it always is. All right, so looking at the last one here, again, we have our sulfate ion, since it has oxygen. So sulfate turns into sulfic acid. Or if you want to call that sulfuric acid, that's fine too. Either way is fine. Okay. Okay. Probably sounds funny to hear sulfic. A lot of times you'll hear that as sulfuric acid. I'll say it as sulfuric acid. But since you're learning the name, guys, it's more important that you realize that there's no hydrogen here. Okay. And once you get into AP chemistry, you'll know that that's sulfuric acid. But for the naming purposes here, get rid of the ATE, put ic. Okay. Also, let's not forget about the hypo. That is removing 2 oxygens from your polyatomic. So if you have 2 oxygens removed, you have the hypo, and since we've already had 1 oxygen removed, we now have ite. Okay. So that'll actually change our acid name, since we only changed the ite to us, the ate to ic. These are the only 2 that we have to worry about. Okay. These 2 right here. The hypo doesn't change. Now, here's what I don't want you to do. Don't think hypo means hydro. Those are 2 different things. Hypo and hydro. Hydro, again, simply means you have no oxygen. Okay? Not the same thing. All right, so let's look at this. HiO2. Hopefully you're looking at that going, that's not one of my 10 polys, but it has 1 less oxygen than one of my polys, and that is iodate. Well, IO2 is iodite. So since it's iodite, we're going to have an us here. So we're going to have, okay, so instead of iodite, we're going to drop the ite ending and put OUS. And then acid. Okay? So iodous acid. Looking at H2CO2, actually we just did something very similar to that, where we had carbonic acid, carbonate, CO3, where we have carbonite. Okay? Since it ends in ITE, we're going to drop the ending and put OUS. And then acid, carbonous acid. Sounds kind of funny, but don't worry about it. So we have 1 less oxygen than our carbonate, so instead of ic, we have us. And that tells everybody, hey, you have a polyatomic that has 1 less oxygen than its normal. All right, looking at ClO4. Well, ClO4 is similar to ClO3, except we have 1 more oxygen. What do you name, or how do you name a compound, or I'm sorry, a polyatomic that has an additional oxygen? Correct, you put per in front of it. Okay? Now, the neat thing is, it still ends in ATE. Okay? So we're going to have the per in there, and then we're going to change the AT ending to ic. So I actually have perchlorate. Since I have perchlorate, the per, okay, if I cover up that per, then I have chlorate, which is ClO3. The per means I have 1 more oxygen. So I need to get rid of the AT ending and put ic, since the ATE ends in ic, and then acid. So you have to be aware of not only the ending, but the beginning as well. So the per, if you're given the name and you're asked to write the formula, make sure you pick up on these keys with the per, the hypo, the hydro, okay, the ic, the us. Okay. All right, then this last one here, since this is chlorate, ClO3, how many oxygens do I have removed here? I have 2. So we're actually looking at a hypochlorite. Hypochlorite. Okay. The hypo is not going to change. We have to keep that in the acid name because that tells us that we have 2 less oxygens on our normal polyatomic. However, we're going to change the ITE ending to OUS. And then, of course, put the word acid on the end of that. Okay? Hope this video has helped. Obviously, this doesn't show you how to do all of the acids, but these are the only types that you need to know. Acids with oxygen and the acids that do not have an oxygen. Okay? So the 2 types. Hope this video has helped.